Okay. Okay, so yesterday we talked about 2 steps to find the inverse of a function. Do y'all remember what those 2 steps were?
Switch X and Y.
Okay, so step 1 was swap X and Y. So again, this is to find the inverse. To find f inverse of X given f of X. So you're going to swap X and Y, and then step 2, solve for what?
Y.
Good. Solve for Y. So that's what we're doing on this problem. This is example 9. It says find the inverse of f of X equals 2 plus the square root of X minus 4. So this is our function. Could you talk to me a little bit about this function before we find the inverse? What do you know about it? It's a square root. It's a toolkit function. And where has it moved?
Right. 4.
Okay, so let's get that toolkit. 0, 0, 1, 1, 4, 2. You said it went right 4, and then what? Up 2. So my new function would start here, and that's my 0, right? Right 4, up 2. So my new function has 0, 0 at 4, 2. 1, 1. My new function looks like this guy, right? Would y'all agree with that? Okay. I just want to have it like a visual, like an idea of what this function would look like on paper. Let me clean that up a little bit because I think this is important. So at 4, 2, our new function begins. And I really think it looks like this, right? Okay, let's talk about our inverse function then. Inverse function. So consider this f of x business as y. So we're going to swap x and y. So that means I'm going to have x equal to 2 plus square root y minus 4. And we're going to solve for y. Step 1. Subtract the 2. So x minus 2 is equal to the square root of y minus 4. Square y minus 4, good. So we're doing inverse operations here. Get it? Inverse operations to find the inverse functions. Great. Love that. So we have x minus 2 squared equal to y minus 4. When I square the square root, I'm left with just y minus 4. And then what? Last move. No, we don't want to distribute the squared. That's an algebra mistake that will break our hearts. Add 4. Add 4. So y is actually going to be equal to x minus 2 squared plus 4. And yesterday we talked about the importance of renaming this. This is called y, but actually y was f of x. And this is inverse. So we want to call this one f inverse of x equal to x minus 2 squared plus 4. So as not to be confused with f. Now, can we have a conversation about what this function would look like? What kind is this? It's a parabola. And where has this parabola moved? Right 2, 1, 2, up 4. 1, 2, 3, 4. Huh. And it looks like this. Can you tell that these two functions are inversely related? Okay, compare their x and y values. We said that this one has a point, the blue one has a point at 1, 2, 3, 4, 2. Can you see that? Its vertex right there is at 4, 2. Well, where's the vertex in my parabola? 2, 4. Huh. They just flip x's and y's. And we looked at that yesterday. Okay, so now I want to talk domain and range. Domain on my blue function up here, this one, and this is what I use to graph f. The domain on the blue function is what? How far left does it go?
4
4
to infinity.
to infinity. Positive 4 to infinity. What's the range on the blue function?
2 to infinity.
2 up, so 2 to infinity. And I need a square bracket at 2. Well, let's look at that parabola. What's the parabola, the purple one's range? Domain. Okay, so the purple one has a domain of all real numbers, or negative infinity to positive infinity. It goes forever. But what's its range?
Wait, is it like a U?
Uh-huh, it's a U. 4 to infinity. Because it bottoms out at 4, and then it goes up from there. Can you tell? So the cool thing about inverse functions is their domain and their range are flip-flopped. So this is domain 4 to infinity becomes range 4 to infinity. This range 2 to infinity looks like it became domain negative infinity to positive infinity, which is not a flip-flop, right? But consider that this blue function only shows the top half of this square root because it's a function, right? So this would be the positive option for the square root of x minus 4. Its bottom, or the negative option, would be a parabola that finished down, in which case its domain would have, its range would have been all real numbers. So when that becomes a parabola, the domain does show all real numbers. Y'all see what I'm saying here? So you can expect that those domains and ranges should flip-flop. There are some special cases like this where they don't exactly, but you could see how that would work, okay? Another fun fact about inverse functions, and we just kind of looked at that, is that they're reflective across the line y equals x. Okay, so let's get a couple of toolkit inverses. It's going to be let f of x be x squared. Let f of x be x squared. Let's find its inverse. So we're going to swap x and y.
Is this like example 10?
This is just a conversation. This is a discussion. Swap x and y. So x is equal to y squared. And let's solve for y. So we're going to square root everything, which means that y is square root of x. Well, I know that when I take the square root of any function or any value, I should consider both the positive and the negative. What that means for me right now is I'm not going to graph a function anymore because it would not pass the vertical line test. But I want you to see what I'm seeing. We started out with f of x equals x squared, which goes through 0, 0, 1, 1, and 2, 4. You guys are really familiar with this parabola, aren't you? Okay, well, I missed all my dots. That's great. Then we landed at y equals the square root of x, which goes through 0, 0, and 1, 1.
Is this supposed to be like a 4 or something? Is that 2?
4, comma 2.
No, I'm talking about where it equals y equals something's plus or minus. Oh,
Plus or minus. Sorry. Check this guy out. Can you tell that it's the same parabola, but it's laid over? Especially, you can see that if you consider the bottom half, the negative square root of x. Okay, again, that keeps it from being a function, but you can kind of see what I'm saying here. Well, functions, when you graph both the function and its inverse, they're actually reflected across the line y equals x. It's pretty cool. So an inverse function is going to have a point that's exactly opposite. So if my blue function has 2, 4, My inverse function is going to be located at 4, comma 2. Neat? Let's look at one more set of toolkit functions and see if we can find their inverse. Let f of x equal x cubed. Can you tell if I flip x and y? You want to take a guess at what f inverse of x would be? The cubed root of x. Good. So if f of x is x cubed, let's get a good color for that. Purple. I grew up in a purple school, so I'm partial to purple. If f of x is x cubed, we're going 0, 0, 1, 1, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 1, negative 1, negative 2, negative 8. Right? So I've got this big elongated S type thing. But it's good. This is good. I did good. Let's go me. Points. I get points. 2 and 8. Yeah, because 2 cubed. 2 times 2 times 2 would be 8. Well, if I graph the blue one separately, what's the cubed root of x when x is 0? Cubed root of x. 0. Cubed root of 1? 1. I don't know the cube root of 2. So we skip out here to the next number I do know, which happens to be what? 3, 4, 5, 6, 7, 8. And what is the cube root of 8? See? And it goes both ways. 5, 6, 7, 8. Cube root of negative 8 is negative 2. This was a bonus question on your test. We didn't do so hot on it. Pretty cool? And if you look, that line, y equals x, runs right through the middle of them. And if you were to fold one function over that line, you would see the other one. What again?
No, I'm talking.
We think the inverse function is if I had the toolkit function f of x equals x. What's its inverse? It doesn't have an inverse. It is itself. So it's kind of one of those I am my own grandpa kinds of deals. It's its own inverse. It's a poem. It's an old poem. Look it up. You'll be fine. That's the end of today. Okay?